Imagine two lines drawn on a plane. These lines represent equations, and together, they form what's known as a system of linear equations. But what exactly is that? Well, it's when two or more equations come together to share a single goal, finding that special point where they intersect. This is where both equations are simultaneously satisfied. Throughout this exploration, we'll uncover the beauty and simplicity behind these mathematical crossroads. So, let's dive in and see why understanding these intersections is crucial for solving many real-life problems. Let's dive into solving systems of linear equations. A classic technique is the substitution method. Imagine two lines represented by these equations, blue for one, gold for the other. Our goal is to find their intersection point. We start with the equation y equals 2x plus 1. Now substitute this expression for y in the equation y equals negative x plus 2. This transforms our problem into a single equation.
2x plus 1 equals negative x plus 2.
Solving, we find 3x equals 1, which gives us x equals 1/3. With this, we can pinpoint the intersection. Calculate y equals 5/3. Here's where the magic happens. On the graph, watch the lines merge to reveal this crossing point. It's the solution to the system, and we've tackled this through substitution, just one method among several. Intersection is solution, a fundamental insight in linear algebra. By approaching these equations with different techniques, you'll see diverse paths unfold. Imagine you are organizing a festival and need to prepare coffee and tea efficiently. But how do you decide how much of each to make? Let's explore this real-world scenario. We start with two key constraints. First, the festival has limited milk, captured by the equation 2 cups of milk for every cup of coffee plus 1 cup for tea, to reach a total of 100 units of milk. This is our milk constraint. Next, time is precious. Preparing coffee and tea takes different amounts of time, leading to our second equation, 5 minutes for coffee, 3 for tea, with a total prep time of 120 minutes. This is our time constraint. Visually, these constraints are lines on a graph. The blue milk line slopes down, showing our milk limits. The gold line, our time constraint, intersecting at a crucial point, the solution. Here's the magic. This point tells us exactly what we need. Prepare 20 cups of coffee and 60 cups of tea. These quantities fulfill both constraints, ensuring everyone's festive cravings are satisfied. As we wrap up, let's highlight the essentials. Systems of linear equations can model real-world constraints, giving us a powerful tool for analysis. We've explored methods like substitution, elimination, and graphical solutions, showing different paths to the same destination. Remember, the intersection of these equations is the key to unlocking solutions. So, are you ready to tackle systems of equations yourself? The journey of discovery awaits.